Hello everyone and welcome to Newton's Academy past paper review for grade 12. We'll be uploading a video every week breaking down one past paper question on a certain topic for math and physics. So this week we'll be doing math paper 2 and we'll be breaking down a question on statistics, this question 1 that we see on the screen. So reading through the question quickly, it says the tuck shop at Great Future High School sells cans of soft drinks. The environmental club at the school decided to have a can collection project for 3 weeks to make learners aware of the effects of litter on the environment. Okay, so not that information in itself is not really relevant. What's relevant obviously is the values that they give us. So the data below shows the number of cans collected on each school day of the 3-week project. That's why we see that there's 15 values, not 21 values, because students obviously go to school 5 days a week. Okay, so we have our values. Then question 1.1 asks us to calculate the mean of the number of cans collected over the 3-week period. So the mean is simply the average of the data values. That means we get the sum of all our values and divide it by the number of values. So question 1.1, we will calculate the sum and divide it by the number of values. So that means we'll add all the values in that table. So 58 plus 83 plus 85, etc., etc. And we divide it by the number of values, and we can see that there's 15 values. So we'll get that to be 1522 divided by 15, and our mean will be 101.47 cans. Right, so that is the average number of cans, or the mean number of cans collected over the on each day over the 3-week period. Question 1.2 asks us to calculate the standard deviation. So standard deviation, thus we use our calculators. They don't ask us to calculate it manually, so you'll use the stats function on your calculator. Just click mode, click number 3 for stat, and the first option, 1 minus variance. You enter all the data values in that table in order, and obviously using your stat function on your calculator, you get the standard deviation, and using that you'll get your standard deviation to be 19.07. So that means each data value is split from the next corresponding data value from approximately 19.07 units. 2 marks. Okay. These calculations where you are required to use your calculator, you don't necessarily have to show working out, especially for these questions on stats. If it's 2 marks standard deviation, you write your answer, you get 2 marks. 1.3, determine the lower and upper quartiles of the data. So there's several ways of doing this question, right? Our lower quartile is known as quartile 1, our upper quartile is known as quartile 3. Now, if you go on your calculator, and again using the stats function, if you click on the option that says min max, it will give you the quartiles and your whole 5-number summary basically. So looking at that, you get your lower quartile to be 89 and your upper quartile to be 113. But if, let's say, for example, your calculator doesn't have this function, or you weren't aware how to use this function, there are other ways in which you can determine the upper and lower quartiles. So the easiest way would be to write out your data values in ascending order, as I have done here. And what you do then is you number each value in the data set. So we see that we have our first value there, we have our middle value, our 8th value there, and the last value, which is the 15th value over there. So what you can do, the first step to determining your quartiles is you determine which number is the middle number. Now in this sequence, we have an odd number of values, so we get simply one number that lies in the middle of the sequence. And we can see that there are equal number of terms to the left, there's 7 terms, and there are equal number of terms to the right, there's 7 terms. So term number 8, which has a value of 100, that's our middle number. Now, what is the lower quartile? The lower quartile is basically the median of the first half of the data. So looking at this section of the data, the first half of the data, the middle number or the median of this half will be your lower quartile. So if you look here, we have 7 values. So obviously the middle of these 7 values is this term here, 89, and that's why if we go again and we look, our quartile 1 was the value 89. And the same is true for the upper quartile. So if we have all our values, if we look for the middle value of the upper half of the data, remember this is the middle value of the data as a whole, and this is the upper half of our data, basically the values that lie to the right of our median. So that is quartile 2, this will be quartile 1, and now we are looking for quartile 3, or our upper quartile, which is the median or the middle value of the upper half of our data. So here's our upper half. We look, there's 7 terms, so obviously the fourth term of those 7 lies in the middle, therefore that will be our upper quartile, and we can see that that is the answer for the upper quartile for 1.3. Now 1.4 asks, use the scale line on the diagram sheet, right? You'd obviously be given a diagram sheet to draw a box and whisker diagram to represent the data, right? So we don't have the diagram sheet here, so we'll obviously just construct our own line to scale. So box and whisker, what does box and whisker show us? The box and whisker is basically a graphical representation of our 5-number summary. So what we can do to help is we first write out our 5-number summary. So our 5-number summary we know is the minimum, it's the 3 quartiles, and then lastly it is the maximum. So we know that we've already identified our quartiles. So we have 89, we have 113, and we have 100 as the median, quartile 2, and then our minimum will obviously be 58, our maximum will be 145. So minimum is 58, maximum is 145. Right. Now using our 5-number summary, we can now construct our box and whisker. So obviously this will be drawn to scale in your answer booklet. So you'll have a number line, and we can start, our minimum is at 58, so we'll start our number line, let's say at about 50. Our maximum is 145, so we can start our number line, or end it rather, at 150. Okay, so we draw our number line, right? This is just a rough sketch, and we have our intervals 60, 70, 80, 90, 100, 110, 120, 130. So we can actually just shift that slightly, right? 140 and 150. Okay, so we have a number line. Obviously this isn't drawn to scale, right? This is just a rough sketch, but for example purposes in your answer booklet you will draw it to scale, right? Now we plot for the minimum and maximum, we plot 2 dots, right? So at the point about 58, so this is 60, so roughly where it's 58, let's say roughly around there, we'll plot a dot for our minimum, which is 58, right? And we do the same for our maximum, so that's 145. We will plot it, let's say in the middle there, so just line it up right somewhere there. Okay, right. Next thing we do is we plot our quartiles. The quartiles are not plotted as dots but rather as straight lines. So our lower quartile, quartile 1, 70, 80, 90, so it will be 89 is about there, so just a straight line, right? 100 as your median, so roughly there, and quartile 3 is 113, which is roughly landing somewhere there, right? We obviously draw 2 more lines to complete the box, and we connect the lower and upper quartiles to our minimum and maximum, and then you have your box and whisker. Obviously you should just go ahead and label it just to be clear. So we have quartile 1, quartile 2, quartile 3, and we have our maximum. So that covers question 1.4. okay, looking at question 1.5, on how many days did the number of cans collected lie outside 1 standard deviation of the mean. So to determine on how many days, which obviously correspond to how many values basically lie outside 1 standard deviation, we need to calculate the first standard deviation interval, right? So 1.5 here, we need to calculate our standard deviation interval, and the equation for that will be your mean value minus 1 standard deviation and your mean value plus 1 standard deviation. So we already know that our mean is 101.47 and our standard deviation is 19.07. So we'll say 101.47 minus 19.07 and we should get 82.4 for the first part of the coordinate, and then we should get 120.54 as the second part of our coordinate. So that is our first standard deviation interval. So looking at our data values, the lower portion is 82.4. There's only one value, 58, that falls outside that lower range. And then 145, we see that it is greater than the high end of our interval. So 120 is what's in the interval. So it's only these two values that lie outside the first standard deviation interval. Therefore, we can say that on 2 days, because it's two values that lie outside one standard deviation of the mean. And that covers question 1. Thanks for watching.